And we are taking a look at topic 6.4, logarithmic functions and inverses. So we are now going to write the inverse of an exponential function or the inverse of a logarithmic function. So here's our process. This isn't much different than what we did. We did it a topic or so ago with polynomials. Same process here, maybe a little bit of difference right there in step 2, but what you're going to do is you'll switch x and y. And then if you're in exponential form, you're going to convert it to logarithmic form. If you're in logarithmic form, you'll convert it to exponential form. Remember that logarithms and exponentials are inverses. We're going to then solve for y. So let's take a look at A. F of x equals 10 raised to the quantity x plus 1. My first step, remember f of x is y. So this is the same as y equals 10 raised to the x plus 1. We're going to switch the x and the y. X equals 10 raised to the y plus 1. And now I can convert this into logarithmic form. I'm going to start by writing log. Now my base is 10, so this is the common log. I don't need to write that base of 10. The argument or the result is x, so I have log x equals the exponent, which is y plus 1. And now we need to solve for y. So I'm just going to subtract 1 from both sides. And so I get log of x minus 1 equals y. Now be very careful. Do not write this as log of x minus 1 equals y and think that that minus 1 belongs to the argument of your logarithm. It does not. Make sure, I use parentheses just to make sure I don't make a careless mistake. That negative 1 has nothing to do with the value of your log of x. So let's take a look at B. Now we're in logarithmic form. So I'm going to go ahead. We already know this g of x is y. Let's flip the x and y. I'm going to have x equals log base 7 of y plus 5. So now let's go ahead and convert this into exponential form. My base is 7. The exponent is x, and the result or the argument is y plus 5. And now I'm going to subtract the 5 from both sides. So I get 7 raised to the x minus 5 equals 1. Let's do a few more. Here's your try it. So this one, A, let's do f of x equals 3 raised to the power of the quantity x plus 2. So again, let's swap the x and the y. I get x equals 3 raised to the y plus 2. And now let's convert that into logarithmic form. Log. My base is 3. I do have to write it. It's not the common log, so I will write the base, whereas in example A, my base was 10. That's the common log. You don't need to write it. So log base 3. My result or the argument is x. And again, I'm going to put it in parentheses to make sure I don't make a careless error. And then my exponent is y plus 2. And now I would need to move this 2 to the other side. It's positive, so I'd subtract it. And I get log base 3 of x minus 2 equals y. And let's do one more. B. G of x equals log base 7 of x minus 2. On this one, let's go ahead and write this as y. Y equals log of x minus 2. Now, when I convert this, oops, log of 7. I'm sorry, I got distracted. I got someone at my door. Log base 7 of x minus 2. Let's go ahead and let's flip this, switch this x and y. X equals log base 7 of y minus 2. Well, before I can convert this into exponential form, I need to move this 2 over because I need to have my log base 7 and my argument here is y. I need to have that by itself. So I'm going to add 2 to both sides. X plus 2 equals log base 7 of y. And now let's write this in exponential form. My base is 7. The exponent is x plus 2 equals the argument or the result, which is y.